So there's a big question if you're just kind of trying to assess how likely is it that we'd find a protein by chance with all the amino acids in that prebiotic soup interacting with each other for, say, billions of years. And I give it a lot of time. How likely is it that we'd ever get a protein to arise by chance? So I have a colleague who's been interested in the whole question of whether or not life could arise by chance for a long time. His name is Doug Axe. He's a molecular biologist. He did his PhD at Caltech. He worked for 14 years at Cambridge University, and he wanted to find out how common or how rare are the functional sequences of amino acids among the big space of all the possible amino acids there are. And he came up with a really amazing number, and it's 10 to the 74 power. So just to get the amino acid sequence properly, you've got an odds of about 1 in 10 to the 74. But there's other probabilistic hurdles that have to be overcome. If you want to build a protein, we know from chemistry that you have to attach the amino acids together with what's called a peptide bond. In nature, peptide bonds occur with about a 1 in 2 in a 1 in 2 frequency. Half the bonds that form between amino acids are peptide bonds, half aren't. But if you get any bonds forming that aren't peptide bonds, you can't form a protein. So to form a protein, 150 amino acids long, you've got a 1 in 2 chance at each site of getting the correct type of linkage. So you've got 1 in 2 times 1 in 2 times 1 in 2 times 1 in 2 to the what power? Close to 150. Since we got linkages, we have 149, but call it 150, okay? So in other words, we got another huge exponential problem to overcome. So, and it turns out that 1 in 2 to the 150 is the same number as 10 to the 45th, 1 in 10 to the 45. So now we got 2 incredibly improbable things that we've got to overcome to build a functional protein by chance alone. One more problem. When you're building proteins, amino acids come in 2 flavors. There's a left-handed flavor and a right-handed flavor. They're called optical isomers, not flavors, okay? And the left-handed version is the only kind that can be used in building proteins. You get even one right-handed amino acid in there and your protein won't fold properly. So you got another probabilistic hurdle to overcome. So you've got a 1 in 2 chance at each site again out to the 150th power. 2 to the 150th power, again, is 10 to the 45. Oh my goodness. So the odds of building even a short functional protein by chance alone is 74 plus 40. You can remember how you do this in math? You can add the exponents if you're multiplying exponential numbers.
164.
Thank you very much. Okay? Wow. Now, can anyone get their mind around a number that big? There's only 10 to the 80th elementary particles in the entire universe. There's only 10 to the 16th seconds since the Big Bang. There's only 10 to the 139th total events since the beginning of the universe. Now you're starting to get the understanding of why people are very skeptical that the chance hypothesis is going to do the job. Now, you may have heard just the opposite. Has anyone ever gotten in a discussion with you about the origin of life and said, hey, it happened by chance? I mean, do you hear that? I mean, this happens to me. I'll be lecturing in hostile university environments, and I'll get done and somebody say, well, but, and they want to argue with me about the probabilities. And I just shut the discussion down because I say, no serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened. No serious scientist thinks this is the way it happened.